we go. Right. Vectors. Here are the two vector equations of the lines L1 and L2. Find the acute angle between them. Remember, when we're talking about... What are you doing? When we're talking about the angle between them, the only bit that we care about, when we're talking about that, the only bit we're interested in is those bits, the direction of these vectors. And so we're going to use the scalar or the dot product to work this out. And it says that cos theta is, remember this bit, a dot b over the magnitude of a times the magnitude of b. So that, in this context, is 2, 3, minus 4, dotted with 0, 1, minus 2, divided by the square root of 2 squared plus 3 squared plus minus 4 squared times the square root of 0 squared plus 1 squared plus minus 2 squared. Top line gives us 2 times 0, 0, plus 3 times 1, plus minus 4 times minus 2. Bottom line gives us square root of 2 squared plus 3 squared plus 4 squared, well that's 16 plus 9 is 25, plus 4 is 29. And this one is root 1 squared plus 2 squared, which is root 5. Are we happy with that? Have I done that right? So we've ended up with 11 over whatever that is, root 145. Is that right? I don't know. Yes. So we're going to do inverse cos of that on a calculator. Do I have to do it? Can I borrow your calculator? Thank you. This one happens to be in degrees, so we'll do it in degrees. Can't do it. Hang on. 11 over root 145. Your screen's got a bit squidgy. Oh man, that's not good. Giving us 24.0 degrees. Do we agree with that? Did anybody else get that? You've got that? Yes? Great. Right. Part 2. Part 2. Show that L1 and L2 are skew. Oh, right. We love doing this. It's one of our favourite bits of doing things. So, part 2, we're going to say if they intersect. Let's think about what would happen if they intersect. It would be true that 3, 0, minus 2 plus S 2, 3, minus 4 would be equal to 5, 3, 2 plus T times 0, 1, minus 2. Have I copied that right? Yeah. Right, and then we compare coefficients to set up our 3 equations. So we think about the I component, 3 plus 2s is 5. The j component, 3s is 3 plus, I missed a t out there, t. There's all sorts of jokes going through my head now, so I've missed a t out. And I'm thinking, anyway, right, minus 2 minus 4s is 2 minus 2t. Right, all we've got to show is that these lines are skewed, so these 3 equations are not consistent. Well, the first equation quite nicely implies that s equals 1. If we substitute s equals 1 into the other 2 equations, then sorry, if s equals 1, we end up with 3 is 3 plus t, so t equals 0. So the solution to the I and j equations was s equals 1, t equals 0. We've got to show that's not consistent with the last one. So in equation 3, I haven't numbered them, but anyway, there we go. If we sub in, if s equals 1, what do we get? Minus 2 minus 4 is 2 minus 2t. We get minus 6 is 2 minus 2t. So 2t equals 8. So t equals 4. That's not consistent, is it? That's not the same as we got here. Not equal to 0, therefore inconsistent. So the lines are skewed. Okay, and I think that's the nicest way of showing that they're skewed. Just going to show that values don't fit on 3. One of the numbers in the equation of line L1 is changed so that the equation becomes that. Given that they now intersect, find A. Well, actually, this is 2 marks. So we're not going to go right back to the beginning and do it all again. We're just going to recognise that that A, that was, what was it? That was the -2 in the bottom line. So, for this last part, the first 2 equations, I and J equations, are the same. Well, we had solutions for the first 2 equations. We had solutions that were s equals 1 and t equals 0. Equation 3 now is a minus 4s is 2 minus 2t. But because they intersect, we know for certain that s equals 1 and t equals 0 fits this equation. So a minus 4 times 1 is 2 minus 2 times 0. A is 6, and we're done. That's a really nice end to that question. I really like that. There we go. Thanks, John.